Okay, let's keep going with question 13. You want to obtain a sample to estimate a population proportion. This is your clue that p hat is involved. That also tells you which distribution to use. At this point in time, you have no reasonable estimate for the population proportion. You would like to be 90% confident. So there is our confidence level. that your estimate is within 5% of the true population proportion. This 5% is your EBP. How large a sample size is required? So they're asking us to find N. Now you have a formula for this one. When you are dealing with a proportion, and I'm pulling this off of the exam 4 handout, it's on the right hand side under sample size determination because that's what we're trying to do. We have that N equals your critical Z squared times P hat times Q hat, all divided by the EBP squared. So we have some pieces to find. Let's see. We have the EBP, that's 0.05. For a 90% critical value, that is on your table. Since this is a proportion problem, proportions always use normal Z. So that value is 1.645 from your critical values chart. Now, they don't give us P hat or Q hat. So this is the case where we are going to use 0.5 for both of them. We are doing that because P hat is not given. So then we go to the calculator. Let me go find my calculator. And I want to do 1.645 squared times 0.5 times 0.5 over 0.05 squared. So that tells me that I need a sample size of 270.6. And in your notes, it talked about how when you're calculating N, you always round up if you have a decimal. We don't want to use partial people. That's just messy. So you need a survey size or a sample size of 271 people in order to be 90% confident. Um, 14 looks very similar. It looks like this time they give you p hat. Remember to find q hat. That's 1 minus p hat. So when you need q hat for your formula, you plug p hat into there, or you plug in p hat to get q hat, and then it should work the same way. Looks like we've got some hypothesis testing coming. So if HO has an equal sign, HA has to be exactly the opposite. So it'd be not equal to. If HA has less than, HO would have to have greater than or equal to, because remember HO gets the equality part. If HO has less than or equal to, then the alternative hypothesis has to be greater than. If HA contains greater than, then the null hypothesis has to be less than or equal to. If the null hypothesis contains greater than or equal to, then the alternative hypothesis should be less than. Okay, so does this one have multiple parts? I don't know, it doesn't say. So we are just going to, in this case, write out HO and HA. The first thing I notice is that someone claims we are dealing with average electronics. That is your big red flashing light that says we're dealing with mu. The next thing I see is at most $3,000. Well, that means the average has to be less than or equal to 3,000. So then I state the opposite. Kids home. So I'm going to make the opposite of my claim. The opposite of less than or equal to is greater than 3,000. Then you have to turn those into your null hypothesis and the alternative hypothesis. Remember, the one with the equal to in it gets you the null hypothesis. This top one, our original claim, but don't write with the highlighter, has the equality part, so it is going to be the null hypothesis. But also remember that we change the inequality to an equals so we can plug it in StatCrunch and run the data. That means that bottom statement is going to be the alternative hypothesis, and it will be that the average is greater than 3,000. Same idea. The only difference I see is that here we see probability. So that means you're going to use P when you're writing your statements, your claims. Question 18, I see a proportion again, so that means you're going to be doing similar things. Same thing on 19, same thing on 20. 21 says it's part 1 of 6, so I can only assume that we've got to do the whole thing here. So we need to come up with our original claim and its opposite. It says it's commonly believed that the mean body temperature tells me we're dealing with mu, of a healthy adult is 98.6. You are not entirely convinced. You believe that it is not 98.6. You collected data using 47 healthy people and found that they have a mean body temperature of 98.25 with a standard deviation of 1.11 degrees. Use a 5% 5% significance level, or 0.05, to test the claim that the mean body temperature of a healthy adult is not 98.6. So we need to state our claim first. Our claim is right here. Our claim is that the mean body temperature of a healthy adult is not 98.6 degrees. So average is not equal to 98.6. So then we write the opposite. The opposite of not equal to is equal to. Now we choose our HO and our HA. Remember, HO needs the equality part, so the opposite statement this time has the equality. So this is going to become our HO. HO says that mu is equal to 98.6. That does not say 98.6. That means our alternative hypothesis says mu is not equal to 98.6. And I am going to mark that alternative hypothesis as our original claim. Now let's look at what we've got. When they did the study, we have a sample size of 47 that had an average temperature, that should be, well, yeah, it works, of 98.25. And we have a sample standard deviation of 1.11. They also tell us that we want alpha of 0.05. So now it's time to go to StatCrunch. Before we can go to StatCrunch, we need to decide the distribution we want to use. In this case, we're using the average. And we do not have the population standard deviation, so we're going to go with student T. So I'm going to go to stat and T stats. I have one sample with a summary. I have a sample mean of 98.25. I have a sample standard deviation of 1.11 and a sample size of 47. We're going to do a hypothesis test for mu, where my null hypothesis was that mu is equal to 98.6. HA says it is not equal to 98.6, and I'm going to compute. That gives me a p-value of 0.0359. So now I need to compare that to my alpha. I'm running out of room, so I'm going to run up here to do that. P was 0.0359. Alpha was 0.05. That means P is definitely less than alpha. So when the P is low, HO has to go. That means, and I'm going to stick it down here, I know it says question 22, you'll be okay. That means we are going to reject the null hypothesis. And then if you go to your exam 4 handout, where it talks about hypothesis testing, or you go in your notes and you look at the table for hypothesis testing, if we reject the HO and the original claim is the alternative hypothesis, that means there is sufficient evidence to support the claim that the mean body temperature is not 98.6 degrees. And I got a little excited with my decimals, so we'll take that out. Well, that was fun. So 22 has you go through the same process all over again. Let's see. The owner of a football team claims that the average attendance at games is over 708, and he is therefore justified in moving the team to a city with a larger stadium. Assuming that a hypothesis test of the claim has been conducted, and that the decision is failure to reject the null hypothesis, state the conclusion in non-technical terms. So, the guy is claiming that average attendance is over 708. So mu is greater than 708. The opposite would be that mu is less than or equal to 708. That means this would become our HO, and the original claim would be the HA. It looks like all of the testing was done for us, and we have a failure to reject the null hypothesis. The original statement was HA, so if you go to your table, under failure to reject, that's the bottom option. When the original claim is the HA, it says there is not sufficient evidence to support the claim that average attendance is greater than 708. So if we compare that to the answer choices, there's not sufficient evidence to support the claim that mean attendance is greater than 708 is that guy right there. Similar process with this one. On 24, all you have to do is find the p-value. It looks like we do not know standard deviation. That means you're going to run a student t. So follow the steps for your student t distribution and finding the p-value. Make sure when you do that you change the sign on your alternative hypothesis when you enter all of your data. The attorney question came out of your homework. We are claiming that new attorneys work fewer hours than the national average. New attorneys work fewer than 48 hours a week. Make the opposite. Come up with your N, sample of 28 attorneys. The sample average was 46.5 hours. We have a normal distribution with a population standard deviation of 5.4. So it looks like you can use a normal Z distribution to find your p-value. When you pick your HO and your HA, it looks like the opposite of the claim is going to be your HO. So that would be mu. Normally it would be greater than or equal to 48, but we switch the greater than or equal to an equal sign. That makes the original claim the HA. And we would have mu less than 48. Make sure you mark that as your original claim so that later when you're comparing your P to alpha, you know which way to go on your chart. Similar idea here. You're using a proportion. They actually put that proportion word in there for you. And they're claiming that P would be less than 0.33. So the opposite of that claim would be P greater than or equal to 0.33. So it looks like you've got HO right here and HA. We do a sample of 1,000 people. We have a P hat of 28.7%. And it looks like we need an alpha of 0.05. Now, when you plug this in and run the proportion stats with the hypothesis testing, you're going to run the proportion stats with one sample and a summary. The catch is you need number of successes. Remember, the number of successes, that's the X value, is P hat as a decimal times n. So in this case, your number of successes would be 0.287 times 1,000. That means your x value would be 287. It looks like we need to run it through so we can make a conclusion. So I'm going to go to stats and proportion stats with a summary. We had 287 successes out of 1,000 observations. Our HO is going to be P equal to 0.33. Our alternative hypothesis is going to be a less than 0.33. I got a p-value of 0.0019. We need to compare that to alpha. Alpha was 0.05. This tells me that p is definitely greater than alpha. That means we fail to reject the null hypothesis. So you go to your notes. You go to the fail to reject the null hypothesis section, and our original claim was the HA. So that means we do not have sufficient evidence. To support the claim. Same idea with the tires. The difference here is that this time they ask you about left-tailed, right-tailed, or two-tailed. Realize or remember that this comes from your HA. (29) is another hypothesis testing. It looks fairly straightforward. The only thing I see in 29 the company just invested and wants to perform a test to determine if more fans attend. So it looks like we want mu to be greater than 13,500. So then 14 would be your N for your sample. Average attendance for that sample would be 15,200. They know the standard deviation for every game, so they are giving you sigma, which means you can run a normal Z. And it looks like your alpha is 0.03. That looks like it's about it.